Hey, Algebra 2 students. This is Mr. Shack, and this is your Module 8 and 9 test review video tutorial. This is a long review, as you know, because if you're watching this, you probably have it in front of you. So with that being said, I need to cruise through it if I'm going to get through all this within my 30-minute time that I have to make videos. But with that being said, remember, there's no way you are understanding all of this review in 30 minutes. There's just no way. So make sure you're pausing, rewinding, using this video in a way that is useful, not just watching it, copying everything down. That's not going to help you review at all. Be trying to do these on your own, then checking with the review or with this video to see that you got it right or where you made a mistake, or maybe just try as much as you can. Where you get stuck, hit the play button, and the video will get you unstuck. But make sure you're using it in a way where it's not just copying down. That's not going to teach you anything, and that's definitely not going to prepare you for the test. So starting off right away, like I said, I got to go quick. So we have a horizontal, or how does the horizontal asymptote of f of x equals 3 to the x minus 5 plus 2 compared to the horizontal asymptote of g of x, okay? Well, our horizontal asymptote is our k value when we're talking exponentials. Okay, so if we have a plus 2 here and a negative 4 here, that's a difference of 6, and that is described by b. Okay, so that's how fast I got to go. So make sure you're not just listening to this and copying the answers. Like I said, that's not going to teach anything. So pause, rewind, think about each of these, and then watch. Okay, determine the following regarding the function f of x equals x e to the x minus 4 minus 7. Okay, well, domain, it's an exponential function, so that's always going to be all reals. Whenever you have an exponential function, your domain is going to be all reals. Your range is always going to be greater than your asymptote, unless there's a negative out front. And that's going to flip it, and then it'll be less than your asymptote. But here we have k minus 7, or k equals minus 7. So our range is going to be all above that. Y is greater than negative 7. And if you struggle with seeing these things without a graph, that's okay. Put it in your graphing calculator. You can see this be graphed then, and maybe this will be easier for you. For the y-intercept, remember x is 0 along the entire y-intercept. So I would go ahead and I'd say, okay, if I'm going to plug in a 0 for my x, that's, I'll just write it here, e to the 0 minus 4, which in other words is just e to the negative 4 minus 7. I would plug that into my calculator following PEMDAS, okay, and you get your y-intercept. Remember, x was 0 there, and your y-intercept is at negative 6.98 about when you put that in your calculator. Okay, now your x-intercept, it does exist because our asymptote is below the x-axis, and it's a positive e here, so it does exist. And again, that can be seen by the graph. If that's something that's hard for you to recognize without graphing it, then use your graphing calculator, okay? You have those resources there for you. Don't be afraid to use them. Now, determine the end behavior of 5e to the x. Okay, well here, if we're going to negative infinity, okay, that means we're going left on our graph. And notice how we don't have a k value, or in other words, k is 0. So as we go to negative infinity, this graph, and again, if you don't know this, just put it in your graphing calculator. But I know this graph is going to look like this, and my asymptote is at 0. And as I go into negative infinity, my graph is approaching my asymptote. So as I go to negative infinity, f of x is approaching 0. And then as I go to positive infinity, as x approaches positive infinity, my graph goes up approaching positive infinity as well. Okay, now moving on, we have an investment of $12,450, and it has an annual interest rate of blah, blah, blah. Okay, compounded monthly. I would go ahead and underline everything that seems to be important here. After 5 years is what we're looking at. Okay, so an investment, this is your principal amount. Okay, that's your P, 12,450. That's your P. Okay, here you have your rate. Okay, and this as a decimal is 0.034. I'll change that to a decimal right away. So that means I have 1 plus my rate of 0.034, but it's compounded monthly, so I need to put that over my n. If I see compounded monthly, I know my n is 12 because that's happening 12 times in a year. So I'm putting that over 12, and then I'm raising that up to the n times t. Okay, well, my n is 12, my t is 5. It's over 5 years. This is my t. 12 times 5 is 60, so I can write that there right away, and I am good. And remember here, I am just following our formula, which you are going to be given on the test. You don't have to memorize formulas. Okay, p times 1 plus my r over n to my n times my t. That's what I just did there. Okay, now the area of a property is increasing by 5% each year. Which statement is correct? That's what we want to know here. Okay, well, if it's going up by 3% each year, it's not going to be A, it's not going to be B, it has to be above 1. And by 3%, well, as a decimal, that's 0.03. Add that to 1, and this is what you get. Okay, 3% is not 0.3. That would be if it was going up 30% each year. Okay, from there, number 6, we have now decreasing by 8% each year. Again, 8%, it's not 0.8, that's 0.08. And if it's going down by 0.08, that means we have 1 minus 0.08. 1 minus 0.08, look for which one of those are. Or, wow, I can't talk, but you know what I was trying to say. And it is B. Okay, again, you could have ruled out C and D right away. You should know if it's decreasing, it's not going to be over 1. It's going to be less than 1. All right, moving on. Let's keep cruising. Okay, this time we are given, for both 7A and B, we are given graphs here, and we need to figure out the function that the graph is modeling. Okay, well, the first thing, and there's not one right way to do this, but the first thing I look at is see, okay, here's the asymptote. That means my k equals a positive 3. So maybe I'll even go down here and write plus 3 right away, because that's going to be my k value. And from there, I see there's an E in one of my reference points. And if I see there's an E in one of my reference points, I know that's going to be my base. Okay, and then I'm looking for the point that is one above my asymptote. One above or one below in the other one's case. In this case, it's one above. And this, remember, is H comma A plus K. All right, well, we know let's just slow down here. I was getting excited. Okay, H here, well, that means H is 2. And if H is 2, we know we have X minus 2 because we are following still our parent function of A times your base, which in this case is E. I guess we'll just call it our base still. We'll just call it B for now, to the X minus H plus K. Right, so that's how I know we have an X minus 2 here. I apologize, I wrote off the screen again. Now you can see it up there though. This is what we are following. Okay, now I have my K. My K is 3. So what plus 3 is 4? Well, that's 1 plus 3 is 4. So that means my A value is 1, which I don't really need to write in here. I am good to leave it at this. Now going on to B here, we're doing the exact same thing following this. I called it a parent function before, but just it's our basic rule for how we transform exponential functions. Okay, and here again, I always start by looking for what my k value is because I can always tell what my k value is by looking at my asymptote. My asymptote is here on my x-axis, so my k is 0, which means I'm not going to have a plus anything or minus anything out here. Okay, and then like I said, I'm looking, oh, I have an e in one of my reference points, so I know my base is e. I also notice that it's a negative e, or that my whole exponential curve, it usually goes up like this, like it did in A, but it's now all below the x-axis, or it's going down. This is exponential decay, so that means I have a negative out front. Okay, and then I'm looking at that point that is either one above or in this case one below my asymptote, and I remember that this is written as h comma a plus k. So that means my h is negative 2, which x minus a negative 2, that's going to be an x plus 2 that I see up here. And then my a plus my k, well, my k is 0, so that means this is just going to be my A, which is -1, which, yeah, I threw that negative out front. I knew there was going to be a negative, and it is a -1 out front. So if you want to write -1e, that's the same as saying -e to the x plus 2. Okay, let's keep moving. 8, now we have compounded continuously, but it's an investment that has an annual interest rate of 6%. Okay, so maybe right ahead, go ahead and say 0.06. That's 6%. That is my R. Okay, compounded continuously, that's going to be an E involved, and that's how I know I'm going to be using my P to the E, or P times E to the RT. Okay, what is the value of a $1,500 investment to the nearest cent after 10 years? Okay, well, here is our investment. That's going to be our P, and then our 10 years is going to be our T. So now I'm just going ahead and I'm filling all these in. If it's compounded continuously, I know I have my E and I have my P times my E out front. Okay, my P is 1,500, so that's the investment. To the RT, well, my R is 0.06. My T is 10. Okay, and then we just need to go ahead and do the math here. Well, 0.06 times 10, I would clean up right away and rewrite this as 1,500 times e to the 0.06 times 10 is 0.6. Okay, then in my calculator, I do e to the 0.6 times 1,500. All right, and I get about 2733.18. Okay, that's a rounded answer. Should be right around there. Okay, moving on. Number 9, we have a function 3 to the x is translated 4 units to the right to create g of x. Okay, well, again, we're kind of going back now to this and knowing that, A, this is our vertical stretch factor, this is our horizontal stretch factor, this is going to move it left and right, this is going to move it up and down. Okay, so if I'm going 4 units to the right, that means my h equals 4, a positive 4. Okay, so that means I now have 3 to the x. Well, we know these are written as to the x minus h, and if my h is 4, that means I have an x minus 4. Okay, so then going on down, same type of thinking here, translated 2 units to the left and then 5 units down. Okay, well, if I'm going 2 units to the left, you need to recognize what your h is. And again, I haven't said it in a while, so if you're not doing these on your own, okay, stop, pause it, think about these, try these, and then check your answers with this video to see where you went wrong, if you went wrong, or not. Okay, you should not just be copying and listening to me do all this for you. That's not going to help you out much. Now, going ahead, 3 to the x is translated 2 units to the left. That means my h is -2. 5 units down, that's talking about my k value, and that is going to be -5 if we're going down 5. Because remember, k is what moves it up and down, h moves it left and right. Okay, now we just put this all together. We have 3 to the x minus h. Well, if h is -2, x minus a -2 is actually like saying x plus 2. And then 5 units down, k equals -5. So that's like saying I have a plus a -5 or just a -5 out back. Same thing. Okay, let's keep moving. All right, this next one seems like a lot going on, but look at it a step at a time and it's not too bad. Okay, so we have this function modeling the amount of a 45-gram sample of a radioactive isotope that remains after T years. Okay, so we don't know how many years, it's just saying after that amount of time. Okay, how many grams of the isotope to the nearest hundredth remain after 8 months? Okay, well, remember, that means we're trying to find A if our T is 8 months. But T is in years, and this is in months. Okay, so we have to say, okay, well, 8 months is how many years? And we do that by going ahead and saying, oh, shoot, you couldn't see where I was pointing that whole time. Okay, but 8 months is how many years is what we're trying to figure out, because we just need to plug this in for T, and that's going to give us our answer to this problem. Okay, because it's asking how many grams, and that's what A represents. Okay, so 8 months, to convert it to years, it's just saying, okay, the 8 months out of the 12 months that are in a year, do that in your calculator. 8 divided by 12, that's 2/3 or 0.6 repeating. Okay, so that's 0.6 repeating years. That's going to be our T. Okay, so this is our T now. and I need to go ahead and plug that into this equation now. If I have 45 to the e, or times e to the negative 0.24 times my t, which I just found to be 0.6 repeating. Okay, and that's going to give me my answer. Once I multiply all this out, it's going to be a rounded answer, and I got about 38.35 grams. This is a G, not a 9. Okay, 38.35 grams. About. Okay, now going on here, it's saying how many years to the nearest hundredth. Okay, so now we don't know t. We don't know t, but it's saying if A is 15 grams. So now we're going back to our original equation. A is 15, okay, and then we're filling in 45e to the negative 0.24 t, but we don't know what t is, so we are leaving t as t, and that's what we got to find. And the way we do this is by plugging it into our graphing calculator and seeing where this is going to be. Okay, if you're doing it on a real graphing calculator, not using Desmos, you go ahead, you plug exactly this in. So you go y equals 45e to the negative 0.24 times t. Then you're going to go to your table and see where y is 15 and see what your x is when y is 15. Okay, otherwise, if you're using Desmos, I'll hop over and do this really quick. Whoa. And you can really plug it in just as is. 15 equals 45 e to the negative 0.24 times x. Because remember, Desmos needs x. It um, does not like any other variables besides x and y. And you notice here that you can't see exactly where this line is going through the x-axis, but if this is 4, this is 6, that means this is 5. So this is at about 4.5 years, I would say, a little over 4.5 years. And that answer for me is fine because if you're on a real graphing calculator, also you're not going to be able to see exactly where it's crossing either. Okay, so that works for me, saying about 4.5 years, or between 4 and 5 years. Okay. Now going on down here, what is the annual decay rate? Well, this is saying, okay, we need to now recognize what this means. The annual decay rate. Okay, that's talking about the e to the negative 0.24, and that's just something you need to recognize that. Okay, that's what this is talking about. Multiply this out, and you get 0.79. Not multiplied out. Do this in your calculator. You know what I mean? Okay, 0.79, and then it's saying decay rate. Okay, well, for decay rate, I'm subtracting that from 1 always. So I do 1 minus 0.79. That equals 0.21, which means my rate, if I'm putting it in percentage, is 21%. Okay. That's how you're handling a problem like that. I don't know how I'm doing on time. I probably need to pick up the pace here. So let's keep cruising. Yeah. So now we got, all right, number 12, we have a savings account with an initial deposit. Okay, when you see initial deposit, that's your P, annual interest rate of 2.5%. This is your R. Okay, and if we want to put it into uh, decimal form right away, do it. Okay, and then it's compounded monthly, so that means N is 12. Okay, and we want to know what we're at after 4 years. Okay, so from here, that means T is 4. Okay, this is what P is. So then I'm going ahead and I'm plugging it in that formula again. So we have P, which is 20,000, times our 1 plus 0.025, that's our R, over my N, which is 12, okay, to the 48, because remember we're doing 12 times 4, N times T. That's 48. That's where that comes from. Then you just need to PEMDAS this out. So do 0.025 divided by 12, okay, that's about 0.105, okay. Then you need to go ahead, let me make sure that doesn't sound right. Let me do that again. Oops, Come on. Divided by 12. Weird. Yeah, that's 0.002. Okay. 0.025 divided by 12 is 0.002. So that means I have 1.002 raised to the 48th, okay, and then multiplied by 2,000, or sorry, 20,000 out front. So then you need to, again, be following PEMDAS. So we did everything in our parentheses first, dividing and then adding. Parentheses are done. Now we know we got to do exponents before multiplication because E comes before M in PEMDAS. So we do 1.002 to the 48th, then multiply that answer by 20,000, and you should get about 22,100. Okay. Now, these next ones will go quick. Practice these. You need to know how to write exponents as logs and logs as exponents also. So pause and then check these with me, or pause, do 13, check to make sure you did the right thing, and then the rest will kind of follow suit. I guess there's, well, we'll see. Okay, 13 here. We have 4 to the third equals 64. Okay, well, our base, if we're writing this as a base, we have log, and then we got base. Our base is whatever our base was in our exponent. Okay, and then we just need to remember that, okay, whatever it equaled, we write it as log base 4. 64 equals then our exponent. So you always are setting it equal to whatever your exponent is, okay, which means this one we're going to have an equals x. And then we have log base e of 12, okay, but remember when you have a log base e, that's like saying the natural log. Log base e is the natural log. So log base e of 12 equals x is the same as saying ln, natural log of 12 equals x. Okay, going on there, we have what is the asymptote of the graph of the function? Okay, with logarithmic functions, we need to know, okay, our asymptote here is actually our h value. Okay, in exponentials, our asymptote is our k value. Well, in logs, it's a vertical asymptote that we have, and it's going to be our h value. And if we have an x minus 2, that means our h was a positive 2. Okay, and if h is positive 2, that means our asymptote is positive 2, and that is a vertical asymptote. So we have x equals 2. Okay, going on from there, we got number 16. Okay, determine the x interval over which the graph of the function is positive. Okay, again here, I would just go ahead and plug this into your graphing calculator or Desmos. Okay, when we do that, I'll do it real quick here at Desmos, but you can do it in your graphing calculator also. Okay, and we have 4 log x minus 2. Oh, x minus 3, my fault. Okay, and it looks like this, and we can see that it is positive all the way after x is 4. So we say, if we're talking about the x interval where where a function is positive, the x interval where a function is positive, well, that is when x is greater than 4. Okay, or you could say from 4 to infinity. Okay, got to keep moving. Probably running out of time, and I still got 2 pages to go. Okay, so this page I'm going to go really fast, I think, because I do not want to run out of time. So here we have determine the x interval. Okay, same thing. Plug this into your graphing calculator. Okay, you have log base 3 times x plus 2. Determine where it's increasing. You could use your graphing calculator. Otherwise, you could realize that, shoot, what was I going to say? Yeah, plug this into your graphing calculator and you will be able to see. But otherwise, yeah, I guess you can realize here your h is negative 2, this means, and you don't have a negative out front, so your log function it looks like this, remember. It's increasing the whole time. As you go left to right, we're going uphill. So if your vertical asymptote is at negative 2, that means whenever x is greater than negative 2, it's increasing that whole time. Okay, so you had your asymptote there. X is increasing the whole time, or your function is increasing the whole time. I apologize. Okay, And you can see that on Desmos or your graphing calculator if you plug that in. Going on here, if we have log base 9 of x and we are trying to find f of 3, well, that's saying, okay, what is log base 9 of 3? Okay, and this is like saying, okay, 9 to the what equals 3. Okay, so, and you can go ahead and you can plug this into your graphing calculator, plug this in, it'll give you the answer of 0.5. Okay, and plug that into Desmos, your graphing calculator, showing the log function that I've shown you how to use. Otherwise, you're thinking, okay, well, 9 to the what equals 3, and it is 9 to the 1/2, because the square root of 9 is 3, which is 9 to the 1/2. Okay. Now, going on here, this is like saying, okay, log base 9 of 729. Okay, and we're trying to find out what that is. And now, again, you can plug this into your graphing calculator and find it. Otherwise, this is saying 9 to the what equals 729. Okay, and that is 9 cubed. Okay, so your answer here is 3. Okay, from there, now we are going on, and I have, for which value of x does f of x equal negative 1/4? Now, if we are going from there, that means we have to do 16. 16 to the negative 1/4. Okay, that's what this is saying, because from there, we then have to go and say, okay, well, I can put this into my calculator, 16 to the negative 1/4, that is 1/2. Okay, because when you put this in your calculator, that is what you get, 0.5 or 1/2, or you can, but really you just need to know, okay, if we have log base 16 of x, okay, that's saying 16 to the what? And again, it's set equal to negative 1/4. If you are saying f of x equals negative 1/4, this is set equal to negative 1/4. So that means this is your exponent. So 16 to the negative 1/4 is what equals x. When you do that, you get 1/2. Now, same thing here. This is like saying, okay, 16 to the 5/4 equals x. Do 16 to the 5/4 in your calculator, and you get 32. Okay, now going on from there, writing this in exponential form. Again, you know that your base here is your base of your exponent. Your log base is the base of your exponent, and then what it is equal to is your exponent, and then that means the 2401 is your answer. Okay, so that's just something you got to be able to do that way. Now, with number 21, okay, this is saying, all right, we have a population of a city increase by 3% each year. This is your R again. How many years to the nearest tenth will it take until the population of the city increases from 25,000, okay, from 25,000? That means this is your P, and we want to know when it gets to 40,000, which is going to be your A. So that means we have 40,000 equals now my P, which is 25,000, to my 1 plus R, which again, 0.03 because it's 3%, that's 0.03, to my T, which that's what I'm trying to figure out. I don't know what that is yet. Now, again, here, if you're using your like a real handheld graphing calculator, you are plugging this in, seeing when your Y value gets to 40,000 what your X value is, or you can plug exactly this into Desmos, see where that line goes through your x-axis, and you'll see that it's at about 15.9 years. If you said between 15 and 16, that would also work, but you should see that it's pretty close to 16 there, so you get 15.9 years. All right, we are on to the back, the very last page here. Okay, so then we're asked to place an x in the table to show whether the transformation is applied or not. Okay, reflection across the x-axis. Look at this here. You only have a reflection across the x-axis if you have a negative a value or a negative out front anywhere. We do not, so that's not applied. Okay, vertical stretch by a factor of 4. If this was a positive 4, not, or if this was a 4 out front, not a 1/4, that would be applied, but it's a 1/4, so that's a vertical compression. Okay, now vertical translation 5 units up. That would be if k is positive 5, but k is negative 5, so that is not happening. Horizontal translation, 11 units to the left, okay? That means h would have to be negative 11. If we have an x minus 11, that means h is positive 11. So that is not applied. Again,